For 16 days, everything looked normal. The crew laughed, they worked. They floated through the cabin like every mission before them. From the outside, NASA saw a routine flight, another successful mission, another safe return on schedule. But something had already gone wrong, not during re-entry, not at the end, at the very beginning. A single moment, just seconds after launch, had already sealed their fate. And the worst part? There were people who suspected it, people who raised concerns, people who asked questions that never got real answers. Because while the crew orbited Earth, there was a growing realization on the ground. This shuttle might not survive coming home. January the 16th, 2003. Launch day. The shuttle lifts off cleanly, engines roaring, everything looks perfect. But 82 seconds into flight, something small breaks away, a piece of foam insulation from the external tank. At first glance, it's nothing unusual. Foam shedding had happened before. It wasn't considered a major threat. But this time, it was different. The foam strikes the left wing, hard, at nearly 800 kilometers per hour. There's no explosion, no visible damage from the ground. The shuttle keeps climbing, disappearing into the sky like nothing happened. And for most people watching, nothing had. But on board the shuttle, no one knew. Inside that wing was a layer designed to survive the most extreme temperatures imaginable. During re-entry, the surface would face heat hotter than molten lava. And now, that protection might be compromised. Back on Earth, engineers start reviewing launch footage, frame by frame. They see the strike, they slow it down, zoom in, and the more they look, the more uneasy it becomes. This wasn't just debris, this was a direct hit. Some engineers begin asking questions. Could it have damaged the heat shield? Could it have created a hole? Could it be serious enough to matter during re-entry? Because if it had, there was no backup system. No repair option in orbit, no rescue mission ready, nothing. And that's where the situation turns from a concern into something far worse. Because instead of escalating the risk, it gets downplayed. Management starts to lean on past experience. Foam strikes had happened before, and nothing catastrophic followed. So the assumption becomes simple. It's probably fine. But not everyone agrees. Some engineers push harder. They request high-resolution satellite images of the shuttle while it's in orbit. If they could just see the wing clearly, they could confirm the damage, or rule it out. Either way, they'd know. But that request never turns into action. It gets delayed, debated, eventually dismissed. Not because it was impossible, but because it was seen as unnecessary. And just like that, the one chance to truly understand the damage slips away. Meanwhile, 300 kilometers above Earth, the crew continues their mission, running experiments, taking photos, living every moment like a normal flight, completely unaware that the outcome might already be decided. Up in orbit, everything still feels routine. The crew follows their schedule. Experiments continue. Messages are sent back and forth with mission control. No urgency, no warning, because officially there isn't one. But on the ground, the conversation hasn't stopped. Some engineers can't shake what they saw. That impact didn't look minor. It didn't behave like previous foam strikes. It looked violent. They start running simulations. If the foam hit at that speed, what kind of damage could it actually cause? At first, the models are rough, incomplete, but the results begin to point in one direction. Not reassuring, not even uncertain, dangerous. The concern becomes very specific. The leading edge of the wing. That's where the heat during re-entry is most intense. It's protected by reinforced panels designed to take extreme punishment. But if even a small section was compromised, hot plasma could enter the wing. And once that happens, there's no stopping it. Inside discussions grow more tense. Emails, meetings, quiet debates. Some engineers push again for imagery. They don't need guesses anymore. They need confirmation. Because if there's a breach, the shuttle is in serious trouble, but the response doesn't change. There's no clear evidence of catastrophic damage. There's no procedure to fix it, even if it exists. So the conclusion stays the same. There's nothing to be done. And that mindset slowly takes over, not because everyone is convinced, but because the alternative is worse. If the damage is real, then the crew is already beyond help. So the mission continues, day after day. 16 days in total. 16 days where the crew laughs on camera. 16 days where they talk to their families. 16 days where everything appears completely normal. And yet, back on Earth, there's a growing silence around the question no one wants to fully answer. What happens when they try to come home? February 1st, 2003, re-entry day. The shuttle begins its descent.
Aboard Columbia, the red team is awake at this time. They're having their midday meal, taking a break out of turning off all the experiments and getting everything ready for their return home tomorrow morning.
At first, everything is exactly as expected. Columbia glides into the upper atmosphere at hypersonic speed. Outside, temperatures begin to rise rapidly, thousands of degrees building across the surface. This is the most dangerous phase of any mission. But it's also routine, or at least it should be. Then something changes. A temperature sensor in the left wing starts to spike, not gradually, suddenly. Moments later, another sensor fails, then another. Mission control notices. It's unusual, but not immediately alarming. Sensor failures happen, but this starts to stack up. Inside the wing, the reality is unfolding. That small breach, created during launch, is now being exposed to extreme heat. Superheated plasma begins forcing its way inside. It starts eating through the internal structure, quietly, rapidly, irreversibly. Back in mission control, the data becomes harder to ignore. More readings drop out. Hydraulic lines in the wing begin losing pressure. The shuttle's control systems start compensating, trying to maintain stability, but it's fighting something it can't overcome. The left wing is no longer structurally intact, and at these speeds, at these temperatures, there is no margin for failure. Then comes the final moment. Communication begins to break up. Short, incomplete transmissions. And then silence. Over the skies of Texas, the shuttle breaks apart. From the ground, it doesn't look like an explosion. It looks like streaks of light scattering across the sky, almost peaceful, until you understand what you're seeing. Inside mission control, there's no immediate reaction, just confusion, then realization, and then nothing. In the hours after the breakup, there are no immediate answers, just debris, scattered across miles of land, and a question that begins forming almost instantly. How did this happen? The investigation starts quickly, led by independent experts, engineers, and former officials. They go back to the very beginning, not the re-entry, not the final minutes, but the launch. And almost immediately, they find it. The foam strike, the exact moment everything changed. But what makes this different from a simple accident is what comes next. Because the investigation uncovers something deeper. Not just a failure in hardware, but a failure in thinking. The foam shedding wasn't new. It had happened before. And each time it didn't cause disaster, it became easier to accept, easier to ignore. Engineers had raised concerns. They had asked for images. They had questioned the assumptions, but those concerns didn't turn into action. Not because they weren't valid, but because the system around them didn't treat them as urgent, and that's what ultimately defined this mission. By the time Columbia began re-entry, there was nothing left to fix. What mattered had already happened. A risk was seen and set aside. And from that point on, the outcome didn't really change. For 16 days, the crew carried on like any other mission, completely unaware of how serious it was. That's what makes this different. It wasn't sudden. It wasn't unpredictable. It was a problem that was there from the start and never fully faced. And that's why the story of Columbia still matters. Because in the end, it wasn't just about what went wrong. It was about what was known and left unresolved.
Columbia, Houston, UHF comm check. Columbia, Houston, UHF comm check.